Welcome, everybody, and thanks for this opportunity. It's an honor to be the first presenter of these lightning talks. I will be presenting briefly the Ersilia project, which is to create a hub of artificial intelligence models related to global health. So we at Ersilia are trying to address the issue that there is clearly a Western bias in biomedical research. So basically, although most of the population in the world live in low and middle income countries, and the majority of the disease burden in such countries is due to communicable diseases, meaning infectious diseases, malaria, tuberculosis, HIV, among others. Actually, 80% of the drugs in the pipeline of development are actually for non-communicable diseases such as Alzheimer's, cancers, cardiovascular diseases. The reason for this bias is broad. There are many. Among them, mainly it's because there is a lack of investment due to the low return for the pharma companies in developing drugs for such diseases, and that the scientific output, the research capacity of the lower middle income countries is actually quite low. In 2018, it was only 9% of the total publications coming from these countries. So what we tackle this issue by using artificial intelligence, because artificial intelligence based research can first decrease the time for drug discovery, making it cheaper, and increase the number of molecules that are assessed. Very briefly, for those non-familiar with the biomedical research, with machine learning models, what we can do is identify drugs among large panels of compounds, identify the targets for such drugs, the side effects, and even optimize these compounds so that they have a specific characteristics, such as that they can be orally taken, for example. The problem in applying this to day-to-day research for, let's say, wet lab scientists is that they are perceived as black boxes, mainly because most of the papers, even when they are open source, they do not share the entirety of their code, so it's not really reproducible. And also, there are not clear benchmarks for the validation of such models. And mostly, scientists report that the main bottleneck is the lack of people with the ability to actually understand the code and use them in research, in everyday research. So our solution to this is to create this model of this hub of models, harboring different types of models, mostly related to infectious diseases, but not limited to. And so the researchers can go into our model hub and search for the models that they are interested in, and then basically they can run it using a web app. For example, for this paper published recently in a scientific in Cell, it's a predictor of antibiotic activity. So if I am a researcher and I have some drugs that I may think they have antibiotic activity, I can go in the website, I can just input my molecule, for example, halicin, and it will tell me whether it's an active or inactive antibiotic according to this model. Whereas if I put ibuprofen, for example, it will say it's inactive. This is for non-experts in coding, so the majority of biomedical researchers actually. And then, of course, we also provide programmatic access, or our models are stored in Docker containers, so they can download and run in their own environments. So basically, what we are doing at Ersilia is collecting these models. The models start with raw data, mostly coming from experimental labs that has to be processed. Then the model has to be trained and validated first internally, and if possible, externally. So presenting data that it has not already been seen, and when possible, also validated in experimental labs. And what is unique of Ersilia is this deployment. So as I was explaining, we are putting all the models inside our model hub in a way that it's user-friendly. So if I have an input, such as a drug, I can choose the model that fits better to my conditions, and then I get my output without knowing anything about coding. The type of models that we feature in our website, first, there are models that come from the literature. So we just bundle a model that has been developed by others, of course, acknowledging appropriately the original authors of this model. We also have models that we have developed ourselves based on data published by someone else. So for example, in this paper, they publish a great data set for antimalarials. So we may develop a model that predicts whether these molecules are actually antimalarials or not. And finally, we also aim at developing collaborations with research groups. As we said, we are mostly interested in infectious diseases, and we are seeking collaborations in low and middle income countries. So for the moment, we are working with H3D, which is a drug discovery institute in South Africa. So basically, we are just building the largest open source repository to date of ready to use machine learning models, so pre-trained, that they can be already applied to research. Our focus is in infectious diseases, and the mission of Ersilia is to create a molecular scientific community by democratizing the use of artificial intelligence. We are a very recently born initiative. We were just incorporated as a charity last October. So the milestones for the coming year is to have a first release of the platform that contains hopefully over 100 models already, establish at least 3 collaborations with different research groups, publish 1 paper in an, of course, open science peer-reviewed journal, and grow a user community in this first year. The team for now is composed of Eduardo, Michael, and myself. We are 3 molecular biologists by training and chemists, and we are very excited about this new project we're starting. So you can find us here in our website. And of course, you can also check the progress of our platform in this app, or check how our code is going in GitHub, because everything is stored there. So thank you very much for your attention.